Welcome students in Algebra 1 to our Factoring Polynomials Part 2 video. I have some Avril Levigne to start off the video in the background. So we're going to be looking at trinomials that have ax squared plus bx plus c in them. We're going to also factor by grouping, and we'll also take a look at perfect square trinomials. So here we have an area model right up here, and you can see that it's the trinomial 2x squared plus 7x plus 6. So we should be able to see here that you've got your factors on the top and on the side. So the factors there are going to be 2x plus 3, that's the one on the top, and x plus 2, that's the one on the bottom. So we notice that this involves having that leading coefficient, and when I say leading, I mean the first one, being something other than a 1. So these are a little bit more involved, and let's start with, why can't I just do what I did for the other ones? Well, what I can't do is I can't say here that I can find factors of, use the pen tool, factors of c that add up to b. Because are there any factors of 1 that add up to 3? No, they don't exist. Which would make you say, from the previous video, remember that this is a prime polynomial, but it is not. This is indeed factorable. So let's go on to the next slide and look at how we can factor this one by using a table method. So instead of factors of c that add up to b, we are going to find factors of AC with a sum of b. So what is AC? Well, A times C here is 2 times 1. So I want factors of 2 that have a sum of 3. And conveniently, 2 is a prime number. So that's just 1 and 2. Well, that 3x is going to get broken apart into 2 pieces. 2x and 1x. And if you add them, you still get 3x. And that is part of what goes in our table. So you've got your 4-square table again. Your quadratic term is going to go in the first box, and your linear term is going to go into the last box. The 2 factors we just found, the 2 and the 1, 2x and 1x, that's what goes in our other boxes. So 2x there and 1x there. And it doesn't actually matter which one goes in which box. It will still work. Now what we do is like backwards from multiplying in the table method. I need to find the GCF of each column going up and each row going across from right to left. So let's start with the columns. 1x and 2x squared. What is their GCF? It's just x. How about 1 and 2x? Well, they don't have anything in common, but they do have something in common, just the number 1, and it's a positive 1. Okay? And then we have across the rows. What do 2x squared and 2x have in common? Well, they have a 2 and an x. So their GCF is 2x. What about the next one? They have x and a 1. Well, GCF there is a 1, and it's a positive 1. And those are the factors of this trinomial. So our answer is 2x plus 1 and x plus 1. And we factored it. Okay, let's try another one with the table method. So it's the same trinomial, but our b is negative this time. So start the same way. Find AC and find factors of AC that add up to b. So AC is 2 times 1. Again, it's 2. This time b is negative 3. Well, what are the only 2 numbers that are going to multiply to give me positive 2 and add to give me negative 3? Well, if the sum is negative and the product is positive, then that means that our 2 numbers must be negative. Okay, next song is Don't Fear the Reaper from the Blue Oyster Cult. So what are the 2 numbers? Negative 2 and negative 1. Because they multiply to give me a positive 2 and they add to give me a negative 3. Quadratic term in the first square. Linear term in the last square. Break apart our negative 3 or minus 3x into minus 2x and minus 1x. Negative 2x and negative 1x. The way this is going to be different from the one with the positives is that when you factor out the GCF and the linear term here is negative, the number you put here and here, they have to be negative. So the numbers you factor out for the second column and the second row has to be a negative because those x terms are negative. So start here. Start here. 2x squared and negative 2x, still a 2x for the GCF. Here, factor out a negative 1 because it is 1, But if that x term is negative, always factor out a negative. Same thing in this column. Still the GCF is a 1, but we're going to factor out a negative 1. And then over here, the GCF is an x. So our two factors are x minus 1 and 2x minus 1. Notice that I ended up writing the 2x minus 1 first, and it does not matter. Either of these answers are totally acceptable because of the commutative property. Commutative property says I can rearrange multiplication, still true. So the table method's fine, but of course we need to be able to do this in an algebraic way without drawing a little picture and a table. So let's talk about the next concept, factor by grouping. Factor by grouping works for 4-term polynomials, and it also works for those trinomials we were just looking at, but just in a different way. So let's start with this one. So to factor by grouping, first you're going to group the pairs. First pair, second pair. And you're going to find the GCF of each of those. So that's the next step. And BC divided by B is just C. What about the next one? If I divide out a D, what's left? AD divided by D is just A, and CD divided by D is just C. Well, that's an interesting pattern. Look, the insides are the same. Well, that's the key to factor by grouping. Those insides have to be the same there. Now, this part's a little bit tough, so I want you to listen carefully, and I'm going to explain it twice. So now we have B times a quantity plus D times the same quantity. Well, that means I can write it as B plus D in parentheses times that other quantity in parentheses, and we have factored it. All right, so let me again one more time explain that. B times this quantity A plus C plus D times the quantity A plus C is the same thing as B plus D together times A plus C together. Now let's test it out by actually foiling it, okay? First, B times A, or A times B, AB. Outer, B times C. Inner, D times A, or AD. And last, D times C, or DC. And that is the same thing as AB plus, it's right up top, AB plus BC plus AD plus DC. Why did I write it twice? I don't know. But it does indeed check out, and we got it right. Now, how am I supposed to use this method for those trinomials if there's not 4 terms? I bet some of you have already figured it out. Let's look at this one. Start the same way we did when we were using the table method. Find AC and find factors of AC that add up to B. AC this time is 6 and B is 5. What are the factors of 6 that add up to 5? Well, actually, we just multiplied them to find that 6. They are 3 and 2. So 5x is going to break apart into 3x and 2x. So what you're going to do is you're going to keep the quadratic term. You're going to keep the constant term. The linear term gets broken apart, but it still has the same value. So now group together, first pair, second pair. Next song is from the Cardigans. It's called Lovefool. One of my favorites. Okay, what is the greatest common factor of 3x squared and 3x? Well, it's 3x. What does it leave me when I factor it out? 3x squared divided by 3x is x. 3x divided by 3x is 1. Now, the key to factor by grouping is that we know that what's in this set of parentheses here, it's going to be the same as this one. So I like to go ahead and write it in and then think, well, what would I divide out of 2x plus 2 to leave me an x plus 1? I would factor out a 2. So what are my 2 binomials we end up with? Well, this is 3x times x plus 1 plus 2 times x plus 1, which is the same thing as 3x plus 2 times x plus 1, and we are finished. You can check it by foiling, but in order to save some time, I'm not going to write that part out. I'm just going to go ahead on to the next one. Second to last slide, guys. This one and one more, and we're done with this. Now, I understand it might feel difficult now. I promise it will get easier. Start off the same way. Find A times C. Find factors of AC that add up to B. Let me give you a minute to do that. Hopefully you paused it and tried it out, but here we go. AC is 3 times negative 2, which is negative 6, and B is positive 1. So what are the factors of negative 6 that add up to positive 1? Well, again, they are 3 and negative 2. And we need to be thinking about our integer math here, just like we did in the previous video. So, take your trinomial, keep your 3x squared, keep your minus 2, split up that middle term, 3x minus 2x. Now do your grouping. 3x squared plus 3x and minus 2x minus 2. GCF of the first pair is still 3x. And it leaves x plus 1. Now again, I have to end up with x plus 1 here for this to work. Now, how can I take negative 2x, and what can I factor out of negative 2x to leave me a positive x? And it's the same number I can factor out of a negative 2 to leave me a positive 1. It's a minus 2. So again, 3x times x plus 1 minus 2 times x plus 1 is the same as 3x minus 2 times x plus 1. And again, FOIL it to check, but we are done with that problem. Excellent. So the last thing we're going to do in this video is look at the perfect square trinomials. The two perfect square trinomials are the square of a sum, right here, and the square of a difference. Remember, that means we write it out twice and FOIL. We end up with a squared plus 2ab plus b squared. And here, it's the same thing except it's minus 2b in the middle. Now let me get a couple examples. Okay, next is pure imagination from the original Willy Wonka movie. Okay, so the first of these two is a perfect square and the second one is not. Let's look at how we can learn how to tell. Now, what you're going to look at is the first term and the last term, are they perfect squares? Is 4x squared a perfect square? Yes, it is. 9? Yes, it is. Now you need to find the square root of those two terms. What is the square root of 4x squared? Well, the square root of 4 is 2, and the square root of x squared is x. The square root of 9 is 3. So then you're going to look at that middle term. That middle term should be 2 times that first term's square root times the third term's square root. If you multiply it, 2 times 2 is 4 times 3 is 12. And you do indeed get 12x. And this is a perfect square. Notice in the second one, yes, you have your perfect squares on the ends, but you do not have a perfect square in the middle. Or you do not have the correct term for a perfect square in the middle. Because 6x is not 2 times 2x times 3. We will practice looking at perfect square trinomials some more in class, but let's go ahead and factor this one. And we could do it the same way that we did the other problems. AC here is 4 times 9, which is 36. And I want factors of 36 that add up to 12. Did you find them? That's right, 6 and 6. So it's 4x squared plus 6x plus 6x plus 9. Now, first pair, second pair. What does the first pair have in common? 4x squared and 6x has an x, but it's also, they're both even, so it's 2x that you can factor out of that first pair, leaving 2x plus 3. What about the second pair? We know it's 2x plus 3, right? Well, what do you have to divide out of 6 and 9 to leave 2 and 3? A 3. Now look, 2x times 2x plus 3 plus 3 times 2x plus 3 is the same as 2x plus 3 times 2x plus 3. And we can even write that in the most simple way possible, 2x plus 3, the quantity, squared, right there in the corner of the video. And that's all she wrote, folks. I promise with practice this stuff will get easier, but do check on the post for the homework. There are practice problems. I'll send you a link for practice problems, and I'll also go ahead and put some from the book. Thanks for watching, and I will see you guys in class.